So the first question from this table that I'm going to ask, so we're looking at this table. It's, here are the counts in thousands, so these are in thousands, of earned degrees in the United States in a recent year, classified by level and by the sex of the degree recipient. Okay, so the first question is that I want to answer is, what is the probability if you choose a degree recipient, which is on this table, this is what this represents, what is the probability that the person you choose is a woman? So the probability of choosing a woman. What do you think?
It would be 856 over 1626.
What did you say again? I didn't hear the first number.
856 over 1626.
Yes. I want to say that on this one you can write them in decimals as well. Like if you want to do both, you can. But that's your answer, or you could reduce it. I know that they both go into, they're both even numbers, right? Of course, I know they're both even numbers. You don't have to answer that question. I think I got 428 over 813. Okay. What is the probability that you'll choose a man? So, what is the probability that a randomly chosen degree recipient is a man? Say again.
770.
Over. And they're both even, so let's just go ahead and reduce those. Perfect.
Miss Flurry,
Yes.
if you started reducing a fraction, but if there was like it could be reduced more, and you leave it like in that like middle ground, like, you know what I'm saying? Like, would
Yes.
that be wrong?
Like, no.
Okay.
As long as you put the original one, you'd be fine. So even if you reduce this and you like, as long as you have the original one before you reduced it, you'll be fine.
Okay.
They don't like when you just give the reduced answer. Okay, so that's pretty nice, right? Right? Okay. So we are going to talk about conditional probability now. So I know you can't see it, and neither can my e-learners. Okay, so we're going to write conditional probability. I like conditional probability, but it can be a little confusing sometimes. Okay, so conditional probability. What is the probability of event A happening given event B happen? Again, what is the probability of event A happening given, that's what the line means, B is happening? So anytime you read something like that, it's the intersection of the two events. So the intersection is always on top, the given is always on the bottom. So even if I rearrange them, Now this one says, what is the probability of event B happening given event A? You guys, the probability of the intersection is always in the numerator of the fraction. The given is always in the denominator. So what I want to do is I want to use conditional probability. So I want to use these tools. So now you know this. Now what I want to do is apply it. They give this to you on your formula sheet. Remember, I put the formula sheet up on the Schoology page. They give you this on your Schoology page. Now, you have to know what it means. Again, you guys, you already know how to find the intersection, right? If the intersection, if they're independent, you know how to find it. You can find it. Sometimes they'll give it to you. Sometimes they'll give you parts of it, but you have to do this. Okay. So again, this means event A given event B. Event B given event A. This number right here, or this event, always goes in your denominator. The intersection of the two always goes in the numerator. Now, the nice thing is we're going to start off with a table, because the nice thing about a table is that you already know the intersection, right? Because it's given to you in a table. So I want you to look at the handy dandy table again. I'll zoom in, and then I will unbore you in a couple minutes. Okay, so the next one, and you guys, they very rarely are they going to say, what is the conditional probability? Even though that's what the question is. What they'll usually say, what is the probability that you choose a woman given that the person chosen received a professional degree? As soon as you see the word given, you know they've put a condition on it. Okay? So as soon as they put that condition on it, now you have to decide how you're going to write the probability. Okay, so I want to look at this. It says, what is the conditional probability that you choose a woman given the person chosen received a professional degree? Okay, so it's a woman and a professional degree. So where do women or female and professional degree overlap? Where is their intersection? So basically, how many women are professionals? 30. Okay, so we're gonna write it like this. Can you guys see that? Okay, so I'm gonna show you how to write it. So what's the probability that you pick a woman, okay, given that they have a professional degree? So you want the intersection of women and professional degree, and we decided that that was at 30, right? So let me just show you. Female and professional, 30. Now, given that they're a professional, given that they have a professional degree, so where is the professional degree at? It is 74, because that's how many have a professional degree. So again, it's the intersection, excuse me, of women and professional degree. That's where I got the 30. And then the 74 is how many people had a professional degree. So it's the conditional probability. You can leave it like this, or you can change it into a decimal if you want to. But you guys, you should never just go straight to a decimal. You should always write the fraction first. Okay? How are we doing? Okay? I love a chart. Charts are so nice, because you know I'm going to change it up, right? Okay, so now I want you to look at the chart again. Can you guys see that? Okay, now the question is, what is the conditional probability that the person chosen received a bachelor's degree given that they were a man? So they received a bachelor's degree given that they were a man. So how are we going to write that one? because now given that they are male, which is,
So it'd be 529 divided by 770.
yep, so when we write this, is, so the probability of the bachelor's degree given that they are a man, there are 520 men that have bachelor's degree, right? So 520 men have bachelor's degree, and there were 770 men altogether. Okay. Yesterday, we did, I wonder what I did with it. Here we go. So here is David's numbers. He has 4 trials. Okay, so trial 1, trial 2, trial 3, trial 4. So what I want you guys to do is I want you to try to figure out, okay, which one is David and which one is his calculator. So in trial 1, do you think A is him or do you think A is the calculator? Okay, so that's what I want you to do. So is it A is him and B is the calculator, or A is the calculator, B is him? So on these trials, let's see if you guys can figure out. I just want you to know that David is trying to figure out right now which one is him and which one is his calculator as well. So you guys do that for me. Okay, so what did you guys, so how many people, so let's talk about trial 1. A or B? How many people think A is David? Okay. How many think B? So how many think A is the calculator? You thought A was David, right?
Yes.
Okay, I asked if A was the calculator. Okay, David, which one?
A is the calculator.
A is the calculator. You erase things. I think you gave yourself away.
Yeah, that's how you can tell. Yeah. Look at the number. Look at
Well, you know, it is what it is. No, you don't actually, because I can't read right.
Yeah, you should.
My eyes don't work very well.
I think if
So I could have wrote them
This is, okay. So, let's go to this one where it's been erased, okay? Let's go to trial 3 and let's see. So, the debate is A David or is A the calculator? So, let's go with this. How many people think that A is David?
for 3,
Yes, for trial 3. Okay, how many people think A is the calculator? Okay, David.
B was the calculator.
B was the calculator?
I have it right here. I have the proof. I erased it because I wrote it wrong.
Ooh, see? Okay. Let's see. Okay, so you guys. Okay, here we go. So look at these and decide. There's 4 trials, so in each trial decide which one is Cameron, okay?
which trial we starting first?
It doesn't matter. All 4 of them, you just,
Can you please give me one? Like,
I want you to do all of them. I want you to decide on all of them which one is Cameron.
well, I'm in the process for deciding.
You mean you want me to determine if A, is that what you,
Which trial are we doing?
do all of them.
I want you to do each trial.
Which one are we doing first?
Oh, do one. Do trial 1. Okay. Okay, you guys, here we go, because we're going to run out of time just like we usually do. Okay, how many people think Cameron is in trial 1, so this trial, how many people think Cameron is part A? How many people think Cameron is A?
So,
Yes, for sure. It's definitely.
Okay, how many people think the calculator is A?
Computer says yes.
Computer says yes. That's because he flipped a coin. Okay, Cameron, who's your calculator?
The calculator is.
She has an answer sheet.
The calculator is B.
This is the calculator.
I misinterpreted the coin's interpretation. I switched my
Okay, number 2, trial 2. Okay, how many people think Cameron is A? Everyone's like, I don't know now. Okay, how many people think that the calculator is A?
Yes.
Okay, Cameron.
The calculator is A.
The calculator is A. Okay. So, if you do, can you tell if we're random, who's random more? So this is what we're going to do. For yours, because obviously I can't do everyone's because I've got e-learners. So what I want you to do is I want you to figure out how many zeros you picked, how many ones you picked, how many twos you picked, how many threes. Then I want you to figure out how many the calculator of each number the calculator picked. So I want you kind of do like a little chart. So I'll show you the little chart. Oh my gosh, we're going to run out. So you're going to have like 0, 1, 2, 3, 4, 5, 6. I don't know why I started that. And then tallies, right? So I picked 4 zeros. And then you'll do the same thing for the calculator, right? So this will be you. This is the calculator. I want you to figure that out, okay? Just for you guys. Just your individual. And then what I want you guys to do is I want you guys to pack up.